multiplying, dividing. So you're going to take two functions, you're going to add them together. You're going to take two functions, you're going to multiply them together. And then after we do that, we're going to figure out what the new domain is of the result of what you got. So in this example, you have a function that they're calling f that's 4x plus 7. So just as a really quick review, the function 4x plus 7 looks like a line. Okay, it has a y-intercept of 7 and a slope of 4. And it looks something like this. Okay, really quick review. That function has a domain of all real numbers because all lines have a domain of all real numbers. The x is going to go forever to the right, and it's going to go forever to the left, and therefore you can plug anything in you want for x. Plug in 2, you can plug in 2 million. You can plug in -2, you can plug in negative 2.7. You can plug in whatever you want, and that's okay. The other function, which they're calling g, we haven't graphed these yet. Okay, so we will. That's what we're going to do tomorrow is graph square root functions. So it looks something like this, a square root function. It's going to look like half a parabola like turned on its side. Now square root functions do not have a domain of all real numbers. They stop. Like you see how it doesn't keep going to the left? It stops. So what that means is if we take f and put it together with g, your domain's not going to be all real numbers anymore because you're taking a function that has a restricted domain, okay, and you're putting it together with something else. So then basically the sum of them have to, what's the word? Oh, I just lost the word I was looking for. So if you have all real numbers here and something else here, when you put them together, it has to satisfy the domain of both. You can't just be whatever you want if this one had restrictions. So I used an example in first period. So like some of you know Mrs. Wolf has celiac disease, right? So she can't eat gluten, right? You kind of know a little bit about gluten allergies, I'm sure. So if Mrs. Wolf and I go to lunch together and we want to share a meal, we can't just get whatever I want. So I can eat whatever I want. I don't have allergies. I can eat a pancake. I can eat chicken. I can eat whatever I want. Mrs. Wolf can't do that. She can't have a pancake unless it's a gluten-free pancake. So if we're going to share a meal, we have to eat what both of us want to eat. Like, not just me, because I will poison her, and that's not good. Okay, so that's what it's like with the functions, okay? I am like this purple function thing. I can do whatever I want. The blue one doesn't get to do whatever it wants. So when we add them together, they don't get to do whatever they want. They have some sort of restriction because the blue one is allergic to gluten, okay? So what we're going to do is I'm going to show you how to add them together, and then we're going to talk about the domain of the newly created function. So if this is f and this is g, in order to add f to g, you're just going to take whatever it says f is. So 4x plus 7, you're going to take whatever it says g is, so the square root of x plus 2x, and you're going to add those two things together. Now with addition, it doesn't really matter what order you write them in, but just get in the habit of putting, you know, if it says f, put that first, g, put that second, because when you subtract, it matters. And when you divide, it matters. So f plus g. Then if possible, you're going to add like terms. Sometimes you'll be able to, and sometimes you won't be able to. In this case, we have a 4x and a 2x. Those are like terms. So what's 4 plus 2? 6. So we have 6x when we add 4x and 2x. Now the 7 doesn't have any like terms, and the square root of the square root of x doesn't have any like terms. So we can't combine those with anything else either. So once you've combined like terms and you can't do anything else, that's your answer to the first part of the question. That is f plus g of x. So that's what you get if you take the two functions and you add them together. You've created a new function. Okay. Make sense? Mm-hmm. Okay. So now what you have to do is figure out the domain. So there are a lot of things that will restrict the domain. You know of two of them. Okay. The first one is that we are not allowed to divide by 0, right? That was like one of the first things you learned when you were talking about division. You're not allowed to divide by 0. You can divide into 0, you can't divide 0. So like 2 divided by 0. Can't do that.
0 divided by 2.
But that you can do. Now the second thing is we cannot square root a negative number, right? Square root of -2. we can do it with imaginary, but we can't do it with real numbers. So you can't square root negative numbers, and you can't divide by 0. So after you get your answer, you're going to check two things, okay? The first thing you're going to check is, do you have any x's in the denominator? So something like this. Like, do you have x's in the denominator of your answer? Because if you do, we have to do something with that. So do you see x's in a denominator here? No. Okay, so we don't have that, so we're going to move on to the next question. Do you see any x's in a square root?
Yeah.
Yes, we do have an x in a square root, right? And it's right here. Okay. So because we have an x in a square root, x is not allowed to be whatever it wants, okay? Because if x is, say, -7, this does not exist.
So it's like that gluten thing you're talking about?
So yes, so this guy is allergic to gluten. He's not allowed to eat gluten. He can eat gluten, he can eat gluten, he can't eat gluten, okay? And they're all sharing a meal. So we have to make sure that it applies for all of them. So what you're going to do is, if you have an x in a square root, you're going to take that aside, and you're going to make it greater than or equal to 0. The reason we're making it greater than or equal to 0 is because, so actually you don't, so hold on. You don't really need the square root in there, you can take that part out. So you're setting what's under the square root greater than or equal to 0. I guess you could leave the square root in there, but this just makes it a little bit easier. Because if you have a variable in the square root and that variable winds up making the square root negative, then you're creating imaginary numbers which are not real. We don't want that, because we're talking about a function, it has to exist on the real coordinate plane. So you're going to take whatever's under the square root, so this is what it was before, okay? You're going to take whatever's under the square root and you're going to make it greater than or equal to 0. Sometimes you'll have to solve that and sometimes you won't. In this case, you don't really have to solve that. It's like done, like x is by itself. And that is what your domain is going to be. So our domain of this is that x has to be greater than or equal to 0 in order for f plus g to exist in the real coordinate plane. If x is not greater than or equal to 0, so for example, if x is -5, you're going to wind up square rooting a negative, which is bad. That does not give you a real number. So that's your domain. Now, if you don't have this term here, right, so let's say you do the math and you get this, 6x plus 7, then your domain is going to be all real numbers, because you didn't have a square root. So if you don't have a square root, or if you don't have an x in a denominator, then you're just going to assume that your domain is all real numbers.
Or do you have a square root but a number in it?
Just a number like the square root of 2?
Like square root of 2, yeah.
Yeah, then that doesn't matter, because
Okay.
that's just a real number on its own.
Alright.
Yeah, so it only matters if there's an x in there. Now if it's like the square root of this, like x plus 2, then what you would do is you'd take what's under the square root, you'd make it greater than or equal to 0, and then you'd solve. So you'd like subtract 2, and then this would be your domain.
Okay.
X has to be greater than or equal to -2.
Okay.
Alright, let's go to the next one. So the next one says g minus f. So you're going to take whatever g is, whatever f is, and you're going to subtract in that order. So order matters.
This one?
Yeah.
I'm still kind of confused in the first one.
Okay.
Like, I get how you get that over, and still how we get the domain. Let's say there's like a 2 in the x.
Yeah.
Do we count that in as well, or
In where?
like the root? Let's say it's 2 root x.
2x?
Yeah, 2x. Yeah.
That's fine. You would just take 2x instead of greater than or equal to 0. You get the same thing.
So it would still be the same
X is
domain.
greater than or equal to 0. Because when you divide by 2, you still get 0. So
that's
it
just
doesn't
it.
change. It would change if it was like plus, because then you'd have to like subtract it.
So
But in general, if you're taking whatever's under the square root, you're going to set it greater than or equal to 0. And so.
Got it.
Okay, now f is 4x plus 7. Okay. Now, if you write it like this, you're not subtracting f, okay? You're just subtracting the first term of f. So whenever you're subtracting, you want to make sure you put whatever you're subtracting in parentheses. That shows that you're taking all of g and subtracting all of f. Okay, if it's not in parentheses, you're not subtracting all of it. you're just subtracting half of it. You don't want to subtract half of it, you want to subtract all of it. So when it's a subtraction problem or a multiplication problem, something of that kind, you want to make sure you're putting that in parentheses. With addition, it doesn't matter so much, but technically you could write this like this: all of f plus all of g. It doesn't affect the problem that much though, because you're just adding things together. But when you're subtracting, it makes a big difference. And the reason it makes a big difference is because when we go here to subtract all of f, you have to distribute the minus sign. Okay? And if you don't distribute the minus sign, then you're going to get a different number.
I wish I would have learned this last week. This is a question of the SAT.
That's why you usually take the SAT after you take Algebra 2.
Yeah, but I had to take it to the college board and get it, so I'm like,
That's why you try to take Algebra 2 before your junior year.
yeah.
If you can, obviously. Alright, so I have minus 4x and then minus 7.
Senior Mike.
You can always take it again, too, right? They
Take what?
super score. Like your SAT.
No, I know that, yeah. That's what I'm
There's a lot of stuff we haven't even touched.
Yeah, because
Like,
like,
remember, like, this is only the first semester.
So like, I got
get
the
it.
SAT and I was doing good at the first four parts because like graphing.
Anything that we can combine now that I've
Yeah.
distributed.
2x and 4x, huh?
So 2x minus 4x is
Negative 2x.
negative 2x.
Yeah. Yes, I saw.
The other terms you can't combine because they're not like terms. So that would be your answer to g minus f. Okay. Now it looks a little different from what we got here, but in general, it's the same situation. We have a square root of x in there. So we have this guy. Okay. That guy can't have Luton. Okay. Whatever's under the square root, you're going to take and set greater than or equal to 0 to figure out what your domain is. So we do that, and we get x is greater than or equal to 0. So that's going to be the domain of g minus f. Okay. Alright, next one is f times g. So we're going to take f, we're going to take g, we're going to multiply them together, and I'm going to put them in the right order. So f is 4x plus 7, g is the square root of x plus 2x. Now, we have two terms here, put that in parentheses. We have two terms here, put that in parentheses. If you don't put it in parentheses, then you're not taking all of f and multiplying it by all of g. You're just taking parts of them. So you want all of f times all of g. Okay. Now, in order to simplify this properly, you would need to distribute, aka FOIL. So we're going to take 4x times the square root of x and multiply. You get 4x root x, which is a little awkward. But you can't really do anything else with that. So then you're going to take 4x and multiply by 2x.
8x.
A little bit more. 8x squared, because x times x is x squared. So 4 times 2 is 8. X times x squared. Then you're going to do 7 times the square root of x.
7 root x.
7 root x. And then finally we have 7 times 2x.
14x.
14x. Now, of all of that, is there anything we can combine?
Yeah.
What?
The 4x and the 14x.
No, it's 4x.
This is a 4x root
my
x,
bad,
this is
my
a
bad, my
14x.
bad. Sorry.
Then you can. No.
No, that's it.
You can't.
You can't.
So nothing. So you could almost combine this and this, but since this is
I
here, you
didn't see
can't.
that.
And then you can almost combine the roots, but this being a 4x, that kind of ruins it. Now, if this x wasn't here and it was just a 4, then you'd do 4 and 7, you'd get 11, and that would be good. So we just leave it, okay? So this is f times g of x. A whole lot.
This is pretty easy.
Okay, let's talk about the domain. Do you have x's in the denominator?
No.
No. Do you have square roots with x's in them?
Yes.
Yes.
Two.
You have 2. Now they're both the same type, right?
Yeah.
Like, they're both the same kind of square root of x. They're both exactly the same. Now we've already done this a few times. You take what's under the square root and you set it equal to 0. And we get that x is greater than or equal to 0. So it's like the same domain as the other ones because it was the same type of radical.
Oh. What are they?
Now keep in mind, if it's like a cube root of x, that doesn't matter, okay? Cube roots don't have restrictions. You can cube root negative numbers. We just can't square root negative numbers. All right, now the last one, you want to make sure you put in the right order. It says f divided by g. So you're just going to take whatever f is, which is 4x minus 7. You want to put that on top of
Is it
g.
a plus?
Is it a plus? Yeah, it's a plus. So we got f over g. Now, sometimes you can simplify this one, but most of the time you can't. There's really nothing you can do here to simplify that. So that's your answer for the f divided by g part. Now the domain part of this one, this is the harder part. So finding it is easy. You just put f on top of g. Finding the domain is a little bit harder because we have x's in the denominator. Did you see that? Okay, so we're going to start with that part.
Wait, why did you point to 2 after you said denominator?
What?
You said
Oh, I just pointed to both of them. Okay, so if you look at the two domain restrictions we know, we have that x is not allowed, or we can't divide by 0. So if you have x's in the denominator, we'd have to take a look at that. And you cannot square root a negative. So let's look at the first one. We do have x's in our denominator. This is our denominator. If we divide by 0, we get
0.
undefined, like we can't do it, okay?
Okay.
So we don't want the denominator, which is this guy, to be 0. We need this to not equal 0.
It's equal 1.
Well, it could be like -1 too. It just can't be 0. So here's how we're going to solve this. You're going to turn it into like a little equation, and you're going to solve to see what x, like to see what's going to cause x to be 0. So the way we solve this is we can subtract that, and then you can square both sides. Like that. Because when you square the -2, you get 4. When you square x, you get x squared. Then what you would do is subtract x like this. And then factor out a greatest common factor, which is x. And then after you take out a greatest common factor, you set both of those equal to 0. So you get x equals 0 here. And you get x equals 1/4 here. Now, we solved that equation to figure out what x values would make the denominator 0. By doing that, we're assuming that, sorry, not that one, that both of these are solutions to this equation. Now, if you remember, Friday, we did like section 5, that was like solving radical equations. Remember, sometimes we get extraneous solutions. Okay, so you would want to make sure you plug these back in and make sure they're both solutions. When you plug in 0, you get 0 and 0 and 0, so that one's good. But when you plug in 1/4, you get the square root of 1/4, which is 1/2. You get 2 times 1/4, which is 1/2. And 1/2 plus 1/2 is not 0. So even though we've solved this, this one is not a solution to the equation. It's extraneous. So you're just going to cross that one out. Okay, so again, this is section 5 stuff. So we still have this one. Now, because we got this solution to this equation, what that means is that if x is 0, it's going to make the denominator 0. And if you plug it in, you'll see, like, if you plug in 0 here and 0 here, we get 0 down there. Now, if x is 0, we're dividing by 0, which is bad, because that's not going to give us a real number. So this is one of our domain restrictions. It's that
You can't divide by 0.
x is not allowed to be 0.
So
That's one of them. We also have to check
Not
The second part, we cannot square root negatives.
We can't square root this one.
So are there any x's in square roots?
No.
Yes.
Right. Oh, right, my bad. Sorry.
We got this one. Okay, so we have that one. That's part 2. You're gonna take what's under the square root and make it greater than or equal to 0. That's your part 2. Then what you have to do is combine these two. Okay? So if I had to combine that into one statement, what could I write instead of both of them? I have x is not allowed to be 0, and I have x has to be greater than or equal to 0. I need to combine both of those into one expression, one inequality. X is bigger than 0. So that is your domain. Instead of writing x can't be 0 and x has to be bigger than or equal to 0, when you combine those two together, you just get the x has to be greater than 0. So it's just instead of x being greater than or equal to 0, you just take out the or equal to because of this part. Okay? So we would have just had x is greater than or equal to 0, but because we have this denominator thing going on, x is not allowed to be 0 either, because then we're dividing by 0, which is no good in math class. We have like 2 things that we have to look at. Now sometimes you won't have anything to look at. Sometimes you will never have, sometimes domain is just going to be all real numbers all the time. So it just depends on the original functions and what they are. If you don't have x's in the denominator, or if you don't have square roots with x's in them, then you don't have to worry about the domain, it's just all real numbers. Now, a real quick side note, so that was f divided by g. If it was g divided by f, it would look like this. Okay? This is different. Okay? So if it's g divided by f, first, you're going to do the same thing you did before. We have x's in the denominator. This is our denominator. We don't want the denominator to be 0. So we're going to take that and set it equal to 0 and solve. Now, if I solve this, I can subtract 7 and divide, and I get x is not equal to -7 over 4.
Yeah.
That would be part 1. You would still combine that with part 2 because of the square root. Now the square root says x has to be greater than or equal to 0. Now if I had to combine these two together, x is greater than or equal to 0, but x is not allowed to be -7/4. So what numbers are greater than or equal to 0? Give me examples.
1.
1, 2,
3,
3,
4.
4, 6.
7.
Okay, as you're going,
12.
is -7/4 part of that set?
Yes.
Where?
It's not.
It's not greater than 0, so it's not part of that set. So what that means is, if we need to put these two together, we don't actually need this part because this one includes that anyway.
So that's just different. That's why you passed it out to 1/4.
No, that was just an extraneous solution. Yeah, we crossed that out for a different reason.
Okay, so
Yeah.
So the 1/4 we got from solving part 1.
then you plug it back
Crossed
in.
it out because when you plug it back in, it doesn't actually work. It's an extraneous solution. Different reason over here. Right, so here we found domain, we're trying to put them together. This domain is already included in this domain. It's kind of like, it's like someone saying like, I'm allergic to dairy, or like, I'm allergic to dairy and I'm allergic to milk. Like, obviously, if you're allergic to dairy, you can't have milk, so you don't need to say both. That's stupid. You would just say, I just can't have dairy.
So x
It's like
doesn't equal
included.
0.
Hmm?
X doesn't equal 0, you can say?
Not 0. -7/4 is the one we're talking about.
Right.
So in this case, you would just say x is greater than or equal to 0 and stop there. You wouldn't need to include that because that is not in this set anyway. So when you state your domain, you're looking for the overlap of the two functions, like the domain of both of these. So And the only two things you need to worry about right now for domain is, are you dividing by 0 or are you square rooting a negative? So if you don't see an x in the denominator somewhere, or if you don't see the x in a square root, then you just don't worry about it. You just move on, you say all real numbers. Okay. Later on we'll do other types of domains. It's called a composition of functions. So a composition of functions, you're going to see a little circle-y shape. It kind of looks like multiplication, but it's hollow. Okay, so it's an open circle. So this means the composition of functions. You're going to take whatever letter is second, and you're going to plug it in to the first function's variable. So whatever the second function is, you're substituting it into the other function for its variable. So this is g. This says f of g of x.
That means
That means take g,
yeah,
which is this.
and multiply it by f.
No, not multiplying.
I
You're
thought-
substituting it in for x's variable. Okay.
Oh,
Or
it's
for
x.
f's variable. So instead of having x minus 5, you're going to substitute in g for this x. Okay? So instead of having x minus 5, you have x squared minus 2 minus 5. Okay? And then you would simplify. Now, there's not too much you can do to simplify that. I would just take the parentheses out, and you're done.
Is the circle supposed to be multiplying?
Oh my gosh. The circle means composition of functions. It means take the second function and plug it into the first function. It doesn't mean multiply. If it meant multiply, it would be a multiplication symbol.
Wait, so
So the second one says g of f of x. You're going to take f and substitute it into g. This is f. And you're going to substitute it into g where there is an x. Now, if you look at g, there's two x's. So there's one here, and there's one here, which means we're going to have to substitute it into two places. Okay? So if g is x squared minus 2x, instead of putting x, I'm putting whatever f is. Okay? And then you have to simplify that.
So wonderful.
Okay. Now when you simplify this, when you have a binomial squared, remember you have to FOIL out two of them. Right? You're squaring a binomial, you have to multiply the binomial by itself. So when you square this, you get x squared minus 10x plus 25 when you simplify. Over here, you're going to distribute. And you get that. And then you're just going to combine any like terms that you can combine. So these two, for example, and these two. And that would be your g of f of x.